being a small business, one of the things that we offer, which is very unique for somebody our size, is that we're very vertically oriented. We have significant R&D and engineering capability. We have an excellent design team, but we also have the ability to fabricate, manufacture these large structures and to support them after production. So it's a significant capability that's unlike any for a company our size.
One of the things that Aurora has been doing is expanding its capability for high-quality, low-cost manufacturing. One of the big steps in that recently has been the award from Sikorsky Aircraft of a major piece of the structure for a new version of the CH-53 helicopter.
The H-53 helicopter has been the backbone for the Navy Marine Corps since the early 1970s. Back then, the aircraft was made out of aluminum and titanium. It was pretty heavy, had short mission durations.
What the Marines have asked Sikorsky to do is build a modern version of it, built out of composites. And Aurora has been selected to help in that, both designing and manufacturing key pieces of the new version of the CH-53 out of this graphite epoxy material.
It's going to be lighter weight, it's going to be able to hold more fuel, it's going to go longer legs, and it's going to be able to lift heavier loads.
We're responsible for the design and build of the main rotor pylon, as well as a build-to-print for the nacelle system, which is really a unique structure because it's not only houses the engines, but it's also a maintenance and a work platform.
We're dealing with designs that have never been tried, and some of the complex geometry requires new types of tooling.
It's a complex shape, complex curvatures, complex components. It allows access to the avionics for the aircraft.
The tooling includes all the mold tooling, cure fixtures, composite trim and drill tooling.
So one of the things we're doing now as we complete the tooling is to use the Sikorsky ACE tools to take a hard look and run 3P events to find potential production problems that we may see as we get into it, eliminate them now, focusing on the proper sequence and all of the flows so that we have the leanest possible and highest value product going to Sikorsky.
When Sikorsky awarded us the job of doing the design on the main rotor pylon, they also gave us a weight allocation that our entire system had to remain under.
Weight is one of the key thresholds, obviously, for an airframe that your requirement that you have to meet. So we manage the weight and design to the weight throughout the process.
We started off overweight by a fair amount, approximately 20 pounds. We have moved to a place where our design is 10 pounds underweight, which is a significant achievement for the program.
Here at Aurora, we have a deep understanding and a deep culture for continuous improvement and quality control. And then the last piece, or are they going to be in separate boxes?
They're all separate boxes.
So we established standard work. Standard work is something that we use as a big ACE philosophy at Sikorsky. We follow that standard work, and we continue to work on eliminating and reducing variation. In effect, what happens is our product that we deliver becomes such that it's perfect at the end of the day.
Aurora has a rich heritage in the manufacture of composite structures, from lightweight endurance aircraft to more substantial structures, the kind of structures that we're actually building for the MRP and nacelles.
We're basically known to a lot of people as being engineering excellence, particularly in the area of unmanned vehicles, so we maintain a full complement of aircraft to design and very innovative engineering. What we try to do is leverage that and bring that into the structures that we're going to be supplying to the CH-53K program.
Composite parts require a much more in-depth layup procedure than your standard aluminum part would. So what happens is we have a vertex system that we use that uses a laser projection. So we have a CAD program where we write that gives you all the ply patterns, coordinates it to the tool, and then it projects it onto the tool for the technician so he can follow the laser projector lines for orientation and location of every ply as you're building the part.
If you ask most engineers what motivates them, it's the pursuit of challenge. They like to pursue innovative tasks, innovative designs that have never been done before, and do it well.
The quality lead that Aurora has, a man named Robbie Robinson, he was actually a crew chief on 53s, 53Es, Ds, and even As. And so we have him as a resource, so we have young engineers that may not know about it, but they can just pick up the phone and ask a question to a guy who spent years flying and repairing and being responsible for these aircraft.
We're proud to be on the CH53K program. It's a unique opportunity for us. Very few times in your career do you get to take something from the initial concept and design and see it all the way through, not only through production, but then out into the field. And in this case, the CH53K, which will deliver unprecedented lifting capability, is something that's just outstanding, and we're proud to be a part of that.
For the Sikorsky program and the CH53K in particular, there's been a strong element of knowing that this aircraft is going to be around for years to come. It's supporting our warfighters and helping our troops to do the missions that they have here and around the world.
Carl Schaefer, the program manager for the CH53K program office.
I'm Robbie Robinson. I'm the quality manager for the Sikorsky programs in the West Virginia facility.
My name's Eric Thompson. I'm the lead tool designer for Aurora Flight Sciences.
I'm Bill Fawcett. I'm program manager for the CH53K, nacelles and MRP.
My name's Clint Church, and I'm Aurora's chief engineer for the main rotor pylon.
My name is Ian Bealey. I'm the Aerostructures Design Group Manager, and on the CH53K program I was the Mass Properties Engineer and a Senior Design Engineer.
I'm Dan Brady, Vice President of Aerostructures Business Sector.
Hi, I'm Glenn Ford. I'm Vice President for Quality Control, Quality Assurance, and Continuous Improvement here at Aurora Flight Sciences.